Yes, dear students, in last session we were discussing about logarithms, use of logarithmic table and logarithms. There it only had been seen that how actually logarithm of any number is defined. Logarithm of any number is defined as the power to which base or fixed number must be raised in order to obtain that given number. But before that, what will we define logarithm as a tool? One of the instrument or logarithm is a tool which is used to make the complicated arithmetic problems in a simple way, which is used to solve the complicated arithmetic problems in a simple way. That is the tool which is used to solve complicated arithmetic sums. In absence of calculators, computers and other digital instruments, electronic gadgets, in absence of these instruments, earlier in those days, people used logarithms as one of the tool. Like now how we are using calculators, computers to operate the complicated arithmetic sums, to operate the complicated arithmetic operations. Earlier in those days there were no calculators, computers. In those days logarithms were used as a tool of the mathematics, by using which complicated arithmetic sums were solved. But actually that is the general definition of a logarithm. And logarithm of any given number, in last session we have seen that any given number, whatever the number is, that can be expressed in terms of power of other fixed number. Any number, any given number which can be expressed in terms of power of another fixed number. If you take 160, one example, that can be expressed in terms of a power of 2, that can be expressed in terms of a power of 5, that can be expressed in terms of a power of 10. There 2, 5, 10 all are fixed numbers in terms of which we can express these given number. In that way, actually here we are trying to express any given number in terms of power of 10. If we are able to express any given number in terms of a power of 10, then that logarithm is called as a common logarithm. In common logarithm, all the time what we do, we try to express the given number in terms of power of 10. And that can be done with examples we have seen in the last class, last session. And it is easy to express any given number in terms of a power of 10. That's why we are following this system. Which system? Decimal system. Decimal system means in terms of a tens and multiples of a tens. Multiples of a tens, because so far we are using in our number system 10 as a standard system, metric system. That metric system is nothing but the standard decimal system in terms of a tens. That's why we can express any given number in terms of power of a tens. In that way, how a logarithm of any number is defined. See, the most particular definition of a logarithm of any number is the power. Logarithm of any given number is just a power to which base, that base fixed number, that must be raised. You have to go on raise its power to produce that number. For example, 1000. 1000 is the number. If you want to express that in terms of a power of a 10, it can be easily expressed as a 10 to the power of 3. Then what we have done? 1000 is the number. That number is expressed in terms of a power of 10. 1000 is equal to 10 to the power of 3. 1000 is equal to 10 to the power of 3, where the 10 is fixed number, that is the base, and power is 3. What we have done there? This fixed number base is raised. How many times it is raised? 3 times. Even on raising it by a suitable power 3, if we get this 1000, then it's okay. Or otherwise, if you don't get 1000 on raising this 10, you just go on raise it. You just go on raise this base number, fixed number, to a suitable power till you will get this. Then this power of a 10 itself is a logarithm. That's why logarithm of 1000 is nothing but the 3. Logarithm of 1000 is any number here. Logarithm of 1000 is nothing but the 3. Till this 3, this base 10 is to be raised. Based on that, we are defining logarithm of any number is the power to which base fixed number must be raised. How many times it has to be raised? In order to get that number, in order to get this any number, how many times that base has to be raised? That many times we have to go on raise it, and finally we can express that number, given number, in terms of power of 10. Here what we have done, example, 1000 is equal to 10 to the power of 3. Here 10 is raised by 3 times. It means 10 has to be multiplied 3 times. Why it has to be multiplied 3 times? Because I wanted to express that given number 1000, any number 1000, in terms of power of 10. And in that way, logarithm, there are 2 types in logarithm. One is common logarithm. Common logarithm is the logarithm where the base is 10. In common logarithm, base is 10. And one more logarithm is there, that is natural logarithm or Napier's logarithm. In Napier's logarithm, base is e. Natural logarithm or Napier's logarithm, name of the mathematician Napier. 2 types of log are there. Common logarithm. Common logarithm is the logarithm there the fixed number is 10. Base is 10. Any given number can be expressed in terms of power of 10. One more logarithm is natural logarithm. That natural logarithm is another type of logarithm. There the base is e. What is e? E is Euler's number, whose value is equal to 2.718. And this is called as a Euler's number. Euler's number. Actually, in another way, logarithm is treated as a reverse function of exponential. What is a logarithm? Logarithm is a reverse function of exponential. Reverse function of exponential is a logarithm. In any mathematical equation, there it can be seen reverse function. Here also, logarithm is a reverse function of exponential. Reverse process of addition is a subtraction. Reverse process of subtraction is an addition. In that way, reverse process of exponential e to the power of x, that is an exponential function. Reverse function of exponential is called as a logarithm. And there the base is e. In the Napier's logarithm or natural logarithm, base is e. And what is e? E is a Euler's number. It means any given number can be expressed in terms of power of e. E is a Euler number whose value is equal to 2.718. How we are expressing any given number in terms of a power of 10? In the same way, even we can express any given number in terms of a power of e also. And that the natural logarithm, how is that represented? Common logarithm is represented log to the base 10 or with the base 10. Natural logarithm, how is that defined? Log to the base e. Log with the base e, or in short, this natural logarithm is also written like this: ln, natural logarithm or Napier's logarithm. You might have seen this. Ln is equal to log to the base e. Ln means log to the base e. There are two types of logarithms. Okay, now we have come across the definition of a logarithm. Logarithm is defined as a tool by using which complicated arithmetic problems can be solved in simple way. Logarithm is defined as a reverse function of exponentiation, and logarithm is defined as a power to which base has to be raised. In three ways we tried to define logarithm. Logarithm as a tool, logarithm as a reverse function of exponentiation, and logarithm is a power to which base must be raised in terms of a power. In three ways we tried to define a logarithm. And logarithm of any number is consisting of two parts. Logarithm of any given number is consisting of two parts: characteristic part or integral part. You can say this as a characteristic or integral part, and remaining is mantissa or decimal part. Logarithm of any given number is consisting of characteristic and mantissa, or you can say integral part and decimal part. Let us see example. Here, logarithm of 8. Logarithm of 8. If you want to express this 8 in terms of a power of 10, first we have to define the characteristic of this 8. Then we have to find its mantissa. Characteristic of the 8 is 0, and mantissa of this. Mantissa of this is a characteristic part is 0. Mantissa of this 8 is 0.9031. 0.9031. With help of this, log of 8 can be written like this. Log of 8 can be written 10 to the power of, on adding these two, 0.9031. Logarithm of 8 to the base 10 is equal to 0.9031. Or in other words, we can understand like this. It can be written like this. In other words, how we can write it? 10 to the power of 0.9031 is equal to 8. 10 to the power of 0.9031. 10 to the power of 0.9031 is equal to 8. It means when you multiply 10 by these many times, how many times? 0.9031. If you multiply 10 these many times, 0.9031 times, you will get that 8. Then logarithm of 8 is nothing but the 0.9031. And the logarithm of this 8 is consisting of two parts. One is characteristic part and the other one is a mantissa part. Mantissa. Characteristic of this is 0. Similarly, let us find out characteristic of these numbers. Characteristic of 88 is 1. Characteristic of 888 is 2. Characteristic of 8888 is 3. How I have written these characteristics of 88, 888, 8888? Easily we can write the characteristic of these numbers. just by the method of inspection. By the method of inspection. Method of inspection means by seeing them. By seeing them, we can define or we can find out its characteristic. There we have to see the given number, whether that given number is in the single digit or if it is in a 10th place or 100th place or 1000th place. Depending upon that, its characteristic can be decided. 88, see this given, any given number, this is the given number 88, of which characteristic, why it is a 1? Because 88 is in a 10th place, that's why its characteristic is a 1. Now 888, the given number is in 100th place, 888, its characteristic is a 2. Here 8888, the given number of which characteristic is to be found. This is 8888, the number of which characteristic should be found belongs to 1000th place. That's why its characteristic is a 3. I already told you, characteristic, this logarithm of any number is nothing but the power of a 10. Logarithm of any number is a power of a 10. Here to get the 8, 10 has to be multiplied by these many times. Here to get the 88, 10 has to be multiplied how many times? There we need to find its mantissa. Its mantissa is 0.9484. 0.9484. Overall, 1 plus 0.9484 means logarithm of 88 is equal to 1.9484. Logarithm of 88 is 1.9484. In other words, how can we understand this? In another word, we can understand like this. 10 to the power of 1.9484 is equal to 88. When I multiply 10 by these many times, how many times? 1.9484. When I multiply 10 these many times, 1.9484, I am going to get 88. That's why logarithm of this 88 is 1.9484. This is the power to which 10 has to be raised in order to obtain this 88. In that way, characteristic can be found of any given number easily just by the method of inspection. Whether that given number of which characteristic should be found or to which place it does belong, depending upon that. Whether does the given number it belong to 100th place? If it belong to 100th place, then its characteristic will be 2. Whether the given number does it belong to 1000th place, of which characteristic should be found? If it belongs to 1000th place, then its characteristic is equal to 3. Later we can find their mantissa parts. Once if you find characteristic and mantissa, both together characteristic and mantissa, they will give us the logarithm of a number. How to find the mantissa? That I will tell you. For that we can make use of this table. This table is called as a Clark's table. Clark's, C-L-A-R-K-S, Clark's scientific data book, Clark's table. If you ask in any bookstore, you can get this, which is of cost not more than 40 rupees or 30 rupees. Ask it. You can get this from any bookstore, which will help us in finding the mantissa parts of the logarithm of a number, and also it includes many such data which actually we require throughout our 2 years of a science PU course. It's very, very essential and necessary. If you want, you can buy it today itself. If you buy, then it will help us while solving the sums and numericals, class table, remember. Okay, Mantissa part, how I have written 9031 9.9484, that is by using this class table. But characteristic part, that can be found easily just by the method of inspection. I already told you, if the given number of which characteristic should be found, if it does belong to 100th place, then its characteristic will be 2. If it does belong to 1000th place, then its characteristic is equal to 3. And like this, we have some rules here to find the characteristic part. You can make use of class table to find the Mantissa, but to find the characteristic, here we have a rule. What the rules are? What the rule is there to find the characteristic? There are actually two rules. First rule: if the given number is greater than 1, of which characteristic should be found. Suppose if the given number, here if it is 8 in this example, 8 is greater than 1, 88 is also greater than 1, 888 is also greater than 1, 8888 is also greater than 1. In this way, if a given number of which logarithm value is to be found, we need to find its characteristic as well as a Mantissa. And if you need to find the characteristic of such a given number which is greater than 1, 8 is greater than 1, 88 greater than 1. If the given number of which characteristic is to be found, if that is greater than 1, then its characteristic, what would be its characteristic? To find it, we have a rule. What that rule is? That rule is characteristic is equal to n minus 1. See, simple formula. If you make use of this characteristic is equal to n minus 1, by using which we can find the characteristic of a given number. What is n there and what is 1? That we will see. This is the formula to find the characteristic of a given number while finding its logarithmic value. Here n is number of, here n is number of digits before decimal point. Before decimal point. Now you apply this formula to find the characteristic of this number. While finding logarithmic value of 8, how I write this 8? I write this 8 as a 8.000. Even if I write that 8 as a 8.00, nothing is going to change in its value. Its value remains the same. Simply what I have done, I have written 8 as a 8.000. Here of this 8, we have to find the characteristic. See that 8, that is greater than 1. Then make use of this formula. What formula is there to find its characteristic? N minus 1. What is n there? N is number of digits before decimal point. 8 is written as a 8.000. 8.000. Before this decimal point, how many digits are there? Only one digit. What's that? 8. How many digits are there? One digit. 8. Then n is equal to 1 here. 1 minus 1, 0. That's why its characteristic is 0. Now while finding characteristic of 88, again I write this 88 as a 88.00. Nothing is going to change its value. 88.00. See that number? 88 is greater than 1. Then how to find its characteristic? Follow this rule. If the given number is greater than 1, its characteristic is equal to n minus 1. 88. Before decimal point, how many digits are there? 2 digits. 1 8, another 8. 2 digits are there. Then here n is 2 for this example. While writing characteristic of 88, n, what is n? Apply this formula. N is the number of digits before decimal point. Before this decimal point, how many digits are there? 2 digits. Then if n is equal to 2, 2 minus 1, 1. Its characteristic is 1. Now come to next. 888. Again 888. I can write it as a 888.00. See now, by finding characteristic of this, how many digits are there before decimal point? 3 digits. What is n there? N is equal to 3. 18, 28, 38. 3 8s are there before this decimal point. N is equal to 3. 3 minus 1, 2. In that way, its characteristic is 2. Like that, of this 8888, characteristic is going to be 3. Suppose if the given number is less than 1, even if the given number is equal to 1, then also we need to follow the same rule to find its characteristic. If the given number is exactly 1, if you find the characteristic of 1, characteristic of 1 is equal to 0. 1 can be written like this, 1.000. Before decimal point, how many digits are there? Only 1 digit. N becomes 1 here. 1 minus 1, 0. Its characteristic is 0. Similarly, if the given number is less than 1, then how to find the characteristic? Look at this example. Log of 0.8. 0.8 of which characteristic should be found? 0.8 is less than 1. This is not greater than 1. And here is another example. Logarithm of 0.08, which also is less than 1. Of such numbers which are less than 1, characteristic of those numbers of which value is less than 1, the rule to find their characteristic is CH is equal to minus of n plus 1. If you follow this rule, you can find out characteristic of that given number which is less than 1. Make use of this minus of n plus 1. Here n is, if the given number is greater than 1, where we have to follow this rule, characteristic is equal to n minus 1. What is n there? N is number of digits before decimal point. If the given number is less than 1, we have to make use of this formula. Which formula? Characteristic is equal to minus of n plus 1. Here what is n? Here n is number of zeros. Number of zeros after decimal point. After decimal point and before non-zero digit. Before non-zero digit. Is that clear? While we are supposed to find the characteristic of such number which is less than 1, then we have to make use of this rule. CH is equal to, characteristic is equal to minus of n plus 1. What is n here? N is the number of zeros after decimal point and before non-zero digit. Now apply the rule for this while finding characteristic of this 0.8. While finding the characteristic of this 0.8, 0.8 is less than 1. Then to find its characteristic, we have to make use of this rule, minus of n plus 1. What is n there? N is a number of zeros. Number of zeros after decimal point. Look at this. In this example, while finding characteristic of a 0.8, here there is a decimal point. After this decimal point, how many zeros are there? No zeros at all. This decimal point is immediately followed by the non-zero digit, which is that 8. Immediate after this decimal point, we come across 8. There are no zeros in between decimal point and 8. It means number of zeros in between decimal point and 8 is that itself is a 0. It means after this decimal point there are no zeros. Before this 8 and after this decimal point, as there are no zeros, n itself is a 0 here. That's why n itself is a 0 means 0 plus 1 is 1. Minus of n plus 1, minus into plus minus, its characteristic is going to be minus 1, or you can write it as a bar 1. Its characteristic is bar 1. Similarly, of this second example, characteristic of this second example, here I am finding characteristic of 0.08, which also is less than 1. 0.08 means its value is less than 1, and if the given number is less than 1, then its characteristic should be found by following this rule. Which rule? Minus of n plus 1. What is n there? N is a number of zeros after decimal point and before non-zero digit. How many zeros are there after decimal point? Only 1 zero, because immediately it is followed by 8. What is 8? 8 is a non-zero digit. That's why after this decimal point and before this non-zero digit 8, how many zeros will come across here? Only 1 zero. That's why n is equal to 1. 1 plus 1, 2. Minus of 2, minus of 2, or you can write it as a bar 2. Characteristic of 0.08 is a bar 2. Similarly, characteristic of this third example, characteristic of 0.008, 0.008 is also less than 1. Then follow this rule to find its characteristic. Ch is equal to minus of n plus 1. What is n here? Number of zeros. How many zeros are there after this decimal point and before this non-zero digit? Non-zero digit here it is 8. Before this 8, after this decimal point, how many zeros here? There are 2 zeros. Then n is equal to 2. 2 plus 1, 3. Minus of 3, or bar 3. Bar 3 is the characteristic of the 0.008. This is how we can find the characteristics of any given number or integral part of any given number by using the two rules. Rule 1, which is applicable if the given number of which characteristic should be found is greater than or equal to 1. And second rule is applicable only for those number whose value is less than 1. To find their characteristics, if the given number is greater than or equal to 1, characteristic is equal to n minus 1. If the given number is less than 1, its characteristic is minus of n plus 1, just by finding these numbers. Already we know in last session 0.1, how is that written in terms of power of 10? 0.1 means 1 divided by 10. 1 divided by 10 means 10 to the power of minus 1. This minus 1 itself is a characteristic. Okay, I already told you characteristic part can be found by the method of seeing, just by watching the numbers, method of inspection. Mantissa can be found by using Clark's table. In next session we will follow this Clark's table, and by using which how can we find the mantissa part so that we can express any given number in terms of power of 10. That logarithm of any number is nothing but the power of a 10. And logarithm of any number is a combination of a 2 characteristic plus mantissa. Combination of integral part and decimal part. Characteristic and integral part both are same. Mantissa or decimal part both are same.